Hello, my name is CoolSpy3. Of my summer projects, I figured that one of them would be finishing up a program idea that I started a while ago. And so I figured I would just make kind of video guide as to my progress. So, start by laying out the basic idea behind this. Essentially, what I want to create is a system which will allow for the creation of a simulated logic gate circuit and then the ability to simulate this with various different inputs and obviously seeing as how that system would evolve. So this is mostly going to be something which is going to go over kind of where I am now, and also somewhat of a refresher for me as I have not looked at this code for a few months now. So without further ado, let's just dive right in. So I believe this is going to be the main file, and as we go through this, I'm also going to kind of talk about what my plans are for this entire thing going forward. But basically, we're just going to go through this and try and just dissect it line by line, and I'm going to attempt to remember how in the world the code works. So starting with the main method, all we essentially try to do here is create a new instance of the main GUI class, and we do this using swingutilities.invokeLater to ensure that this is run in sync with the AWT event thread, because if you don't do that, then sometimes you can get weird results, and I've had this happen before where like occasionally my GUI would render offset, and so this just makes sure that it does it correctly. So having a look at this, that's going to create a new instance and call this constructor here. So we call the superclass constructor with the title of the window, and then we're going to set its size to be 1000 by 1000, and you can see right here that I've set it to not do anything on close, and this is because I believe I've written in my own custom code that I want it to run when the user hits the X button in the corner, and so this will just disable any internal methods that it would normally do, such as disposing the frame or exiting the program. Now, if we do set location relative to null, what this would normally do is it would try to center the window, I believe, on another component or another window. And if we just pass in null for this, it will just center it relative to the entire screen. And so this will just center it on the screen. And then we're going to want to receive window events on this component. So you can see that this implements a window listener. So we can receive events, and this is how we achieve the custom handling of, say, that X button. Then what we're going to do next is we're going to set up the menus, which is in this case I believe a J menu, which is essentially all of these buttons that you can get on the top of the window. And actually, it would be helpful if I had this running to showcase. So this is essentially where we stand, can place down different components, you can connect them, and just how this looks. You can rotate them, and you can delete them. And there's also the ability to save this and reload it. In any case, so this menu is going to be these little buttons on the top. So looking at that method, you can see that we have a bunch of different variables here, but when you get down to it, it's just doing the same thing over and over again. So we create a menu bar, which is going to be essentially this entire whole bar up at the top that is going to store everything, and then each of these J menus, I believe there's another one down here, are going to be these top level drop downs. So we're going to create one with the name file and one with the name options, and you can see that in here. I'll just move this off to the side, and then on each of these we're going to create a number of sub items, and I'll go through how each of these works. So essentially, when you click on the menu, you get all of these drop downs. So going through, you can see we have the new project button, and then we do a few things to it. So we first create it and we set its name, then we do this thing which is set accelerator. And what that is that's this little key combo here. So you can see for new project, we have Control N. So if I go and I press Control N on the keyboard, it will act as if I press that button. So after we've done that, we will add this. So this object, which you can see also implements action listener. So we will receive action events from this menu item, which is basically whenever we click it, we will receive an event. And then we add it to the menu, and we do the same thing for the open and close project. And then for all of these save and render project buttons, we also have this extra line which is set enabled, which will go and it's what makes it so that these are grayed out and we can't click on them because we don't have a project open. We also have these lines in here between them, which are add separators. So if you actually just look at the add lines, we add new menu item, open menu item, close menu item, and then we add separator. And if you go and look at the window, you have new, open, close, and then this bar, which is the separator. So you just continue on doing this, and for the accelerators, you can see that we pass in a keystroke object, I believe. Yes, which is called by calling this get keystroke with a key code and a what's it called? And list of modifiers, which are what's the word I'm looking for? Well, I'll add in editing. In any case, so here we have the key code N along with the masks for the control key down, and so we get control N, and same thing for control O, control W, control S, and then control shift, and then so this is going to do a bitwise OR between these two. So if you think of these as being a bunch of numbers in binary, you can see that like control might be that and shift might be that. Those, something like that. Actually, 128 and 64. So control is going to be 1, 2, 4, 8, 16, 32, 64, 128. So this is going to be control and this is going to be shift. And when we do a bitwise OR between these, it's just going to say 0 or 0 is 0, 0, 0, 0, 0, 0, 0, 0 or 1 is 1, and then keep going like this, and so you're going to end up with a number like that. And then that will give us a keystroke, which we then combine to the accelerator. And so we keep going, we add save, we add render, and then I'll obviously explain what all these do later. And then we add a quit button, and then in the options menu we add a checkbox, and we're going to set it to be checked by default. And then finally we call set JMenuBar, so this, which will actually add it to the top of the frame. Okay, continuing, we're going to set this string file name, which is going to be, I'll explain later, and content panel. So the way this works, if I remember, is the entire frame here in the center is actually not controlled by this class, but rather by a separate panel, which is going to just handle rendering of this frame so that we can, in the future, swap it out to do different tasks and not have to cram all of that into one file. And so for the moment, because we don't have anything displayed, we're just going to set that to null. Then we're going to make the frame visible, and we have then this bit of code here, which is going to create a thread, which is going to continually call this repaint function. So essentially what we do is we're going to create a new thread, and this is going to set up what the thread's going to do, and we're just going to say forever. So for the whole lifetime of the program, if the frame is currently visible to the user, then call repaint, which is going to call later this paint function, which is going to actually keep updating the actual image that you can see. So then we're just going to sleep for a delay, and you can see that this is essentially going to be set to 1000 divided by FPS. So I have this set to run at 60 frames per second, and so you can imagine that if you have frames divided by seconds, and right here we have, and what we want to do is thread.sleep expects a number of milliseconds, and so what we want to get is we want to somehow convert this into milliseconds. And so what we can do is f divided by s. If we take 1 divided by that, we're going to get seconds per frame, and then we have to take this and divide by 1000 in order to turn these seconds into milliseconds. So then if you do 1000 divided by seconds per frame, that's going to give you, 1000 divided by frames per second, that's going to give you 1 second. Sorry, I got myself confused for a second. In any case, so when we take 1 and divide by the number of frames per second, we will get the number of seconds per frame. And then if we do 1000, and then if we multiply this by 1000, we will then get, so if we have the number of seconds that you need for a single frame, then that's going to be something like 0.016, I think, seconds at 60 frames per second. And so if we multiply this by 1000, we're converting this seconds to per frame into milliseconds per frame. And so we will wait for that amount of time and then continue to just run this loop forever to ensure that the frame's always updated. Then we will do this, which is set daemon, which means that this thread won't keep the program running. So normally when you create a new thread, the Java will attempt to run this thread, and as long as any single thread is running, it won't allow the program to terminate, even if you've killed all other threads. And so this just ensures that we don't have to worry about shutting down this thread in order to shut down the program. And then we'll just start that to keep it updated. Right? So then we can start going through, and I believe what happens when any of these events occur. So starting with this action performed method, there we go. There we go, that's better. Starting with this action performed method, you can see that what we call is this e.getSource function, and this will return the element which has created this event. So we can just start going down the list. So when we get a new, when someone goes and clicks the new button, so then what we'll do is we'll call if close content panel, and essentially I'll get into this, but here. So what we say is if we are currently displaying something, then we're going to attempt to do then we're going to attempt to do save unsaved, and I'll come back to exactly how that works. But essentially, it will attempt to save a project if we have it open, and then if it either succeeds or the user chooses to discard changes, then it will go and remove that content panel, set it to null because we're now no longer displaying anything, and disable all of the save buttons. And then we just call revalidate, which means that we're going to update that change in the panel and ensure that this remove function we did actually removes it from the frame. And then if we succeed in doing that, so if there's either nothing being displayed or basically the user doesn't choose to cancel the operation, then we'll return true from this and go back to this. And if they choose to not to cancel closing, then this will just return false and will just exit this function. But if they do, then we'll set file name to null because we aren't opening a file, and we will set the content panel that we're using to a new content panel. So we're going to create a new instance of the content frame that we're going to use for editing, and add that to the frame, enable the ability to save, and revalidate the frame. Next, if you click open, we're going to attempt to create a file chooser. We're going to not allow it to accept all, and actually specifically only allow it to accept what I'm calling LM files. We're going to then only allow selection of files, disable the ability to open multiple, and show the dialog to open it and center the dialog on this window. So if we choose open, then it will do that. And then this will actually just halt the thread until the user either clicks accept or closes or cancels the window. And then what we're going to do is we're going to retrieve the file they selected, and if the file is not set to null, which means they actually did select something, and the file exists, so they didn't somehow select a non-existent file, then we're going to attempt to close the content panel. So the way Java works is that it will evaluate these left to right, and then if any of these fail because they're all ands, then it will just cancel and it won't attempt to execute the rest. So if these two are true, then we'll see if the user wishes to close the current project they have open. And then we're going to set this to be the file that we've opened, and we're going to call getCanonicalPath, which is going to take a normal path, which might look like either or it could be a relative path, so or it could also look like and while these are all valid paths, only this one is a canonical path because it doesn't include any of these dots, which references the previous directory or the current directory, and it contains an absolute path, so it starts with a drive description, or on Linux-based systems, just a / and then specifies directly which file. And so we're going to set that to the file name. We're going to set the content panel, and you can also see content panel takes in an instance of this GUI, so it can reference the actual window, and as well as the file. And then we're just going to do the same stuff we did here to add it to the frame. And if you select close, then we're just going to call this same close function, and we don't need to do any of the stuff we did here to like open a new project. We just want to close it. Save is going to call a save function. Save as is going to call save as, and I'll go over both of these once I've given kind of an understanding of how the rest of the code works. Render is what's actually going to take the project that's in its state of being editable and converting it into something which the program can actually simulate. But for now, I just have it saying that that's not supported. So that's what show message dialog does. We're going to center it on this window, display that message. That's going to be the title of the frame, and this is an error. So that's what the error does. You give the title, and this is just this is just a show message dialog, and so the only option you're given is to say OK. Next up, if you have a quit menu item, if you clicked the quit button, then we're just going to dispatch a window event on this window, and we're going to say window closing, which is the same event that you'd get if you clicked the X button in the corner. And so we're just going to simulate the user clicking that button. Right? And then all of these save functions are going to have an IO exception thrown if something fails. And so in that case, we're just going to log it to the system error log and exit with an error code. Right? So now going into the content panel, you can see that this implements a few functions. Actually, I'm just making sure that there's nothing I want to go over here. Yeah, quickly, window closing. So this is the event thrown when we receive this. So if the user clicks the X, then this method will be called, and that's just going to attempt to close the content panel if it's visible. We're going to make this window We're going to make this window invisible and dispose the frame, which means free all of the resources responsible for it. All right, now moving on to content panel. This is essentially where the bulk of the code is so far. So this is what actually renders this background, what does mouse events, what keeps track of components that are inserted into the frame. This is what does all of that. So what we're going to do is we're given an instance of the GUI, and you can see that we also have this version here where we attempt to open a file, and that's just going to start by calling this code here. So we might as well focus on that. And what that's going to start with is going to call this initComps method, which is going to attempt to load. This just calls class.forName, which attempts to locate this class and load it into memory. And what that ends up doing is that these are all classes in here, and they all have these static blocks in them, which I'll get into later. But essentially, this code ensures that those are run and that they're imported into the system. And so we will go and make sure that all of these base classes are init, because otherwise other parts of the code are going to try to search for them, and they're going to be unable to find them due to the specific way in which they're loaded. Which part of the code is that? I think it's going to be here when it attempts to load a file. In any case, that will just go and ensure that all of these are loaded and we can access them all throughout the rest of the code. Then we're going to create a component selector, which is going to be this window off to the side. So it's going to allow you to select components and add them to the frame. And so you can see that it takes in a window, which is the master, which is going to be the window that is essentially invoking it, and it's going to have a window listener which is going to send events to. So we're going to create it with the title, insert components. We're going to set its size to 320 by 600. We're going to disable its default close so that we can do our own code. going to set the layout to be a grid layout, which means that we're going to have a grid which is 10 rows, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1 column. And that's going to set the layout for all of these button components. And then what we're going to do here is, actually, 1 second, sorry. So then what we're going to do is we're going to create a button group, and the button group essentially ensures that, I have to just keep this open, that of all of these buttons, only one can be selected at a time, because otherwise, why would you want to add, it wouldn't make sense how you're supposed to deal with adding multiple components. So then I've just created this convenience function add button because all it does is it attempts to add the button to the button group and to the frame. And so what we can see is that we first of all define none button, which is just going to be the button which we get if none is selected, so this top one here, which is going to be a JToggle button, and JToggle button is just a button which can stay in either a pressed state or an unpressed state with the text none. And then the rest of these, you can see for each component, we create this lambda component button, which I'll look into in a second, with the icon of a get image function. So the way that images are being handled by this code is that we have a set of load image functions which will attempt to read an image by an alias and a path, and it will just put it into a map which will map that alias to the image that we load from that path. And then we also have one here which will load a series of them for components that handles the 4 different images that you have to get for component rotations. And then you can see that it just does that by loading one and then calling a rotate clockwise function, which is code I grabbed from Stack Overflow, and it will just rotate that image 90 degrees clockwise, and then we save that as different names, so 0, 90, 180, 270, and then we can deal with rotation. And then we also have a method just to add an image directly into the map without having to load it from a file. And what getImage will do is it will use that alias and retrieve it from the map. So we just grab the default names of the images for all of these components and add them as the icon. The dimensions for these images, we then add the dimensions for all of these images, like so. And most of these you can see are 100 by 50, so all of these components use 100 by 50 images. And then we pass in finally a reference to the constructor function of the component that would create. So now just to have a look at what this code does. Essentially, may look complex, but it's essentially just creating a bunch of constructors that do the same thing for buttons. So you can see we have by default a component button, which is just going to be a JToggle button, so something that we can toggle on and off. And it will just be defined as having all the same constructors as that button, but it's going to have an abstract method which is going to return a DComponent, which is just the class name for having a component on the frame. So this is a DComponent at its root, and then given the location at which you want to put it. And so you can see that from that we have a single size component button, which is going to be the exact same as this, but it's going to take in a size dimension. And so what that will do is it attempts to center. So when I click on this, you can see that it centers the component, And so what this does is that it will use the size you provided of the component in order to center the point before calling another function which will get it at that point. So when you create the component, the component is actually stored using its, I believe, top left corner position. So this will instead take the center point and calculate where that point is and pass that on to this function. And then we have the lambda component button, which assumes that the component is going to have a size on it so that it centers it, and it takes in a function which will map the point to the component. And so because all of the components have a constructor which just takes in a point, we can use that as the function which will create the component, and then the get component button will just call that function with the point that it's given. So given that, we will add all the buttons to the frame, and then we will set the none button to be selected, make the window visible, and then we're going to add a window listener to the master window so that we can receive when the window closed event, which is different than the window closing event that you get when you click the X button, but it is when the window is actually closed and disposed. So if that happens, we will set this window to be invisible and dispose it. And then we're also going to save, and then down here we're going to save a reference to this, because what we're going to say is that when the user clicks the X button, we're going to act as if we're going to send a window event to the master window, essentially saying that the X button was clicked. And because in here we don't actually check that it was this window which sent the closing event, we can just say we will say that truthfully that this window is what sent the event. However, if we were to just pass in this here, we're currently inside of a window adapter class and not the actual component selector class, and so we'll save a reference to this out here in this scope and then use it in here, and that allows us to use this keyword as if it was part of this outside scope. And then down here we just have a single function that this class defines, which is get and reset for a point, which is going to essentially look through all of the different buttons that we have, and for each one we're going to, for each button, if it's selected, then that means that, if you remember, because of the button group, we're only going to have one of these selected at a time. And so if that's the one which is selected, then if it is an instance of component button, then that means it's one of these. Otherwise, it's going to be the none button, and we can just ignore it. So then we're going to set it to the get component function. So that will, in this case, in any of these cases, create a new instance of whatever component this button is referencing. And then it will retrieve that component for wherever the user has clicked, which will be what's passed into this function. And then you can imagine that if in either of these cases we don't want to be doing this, we don't have to keep iterating because only one button will be selected, and so we'll exit the loop, and then we'll ensure that none is selected, and we'll return whatever this component was. And if we had received none button, then is selected would be true. Is selected would be true, but because none isn't an instance of component button, we'd just break and out would stay null. And actually, we don't need this line here because it will break in either case. So given that, we'll return that button, and that is the entire component selector class. Now back to content panel, we're going to add a container listener to the content pane of the GUI window, so the overall window, not this pane here, not this here. And what that will allow us to do is receive events whenever a component is added or removed from that frame. And that'll be important because it allows us to detect when our component, so this frame, so this actual content here and the grid and all of the components in it are actually added or are actually removed from the frame so that we can execute our cleanup code. So then we're going to also make sure that we can check when keys are pressed, when the mouse is pressed, when the mouse moves, when the mouse scrolls, and we're going to allow focus to be put onto this component so that we can actually receive all of these events, because we can only receive it when it's focused. So then this is just essentially initializing all of the defaults that we need for the frame. So drag components, when we have components in the frame, you can see that we can drag them around, and so it's going to be the list of that, because you can have 2 of these and they can be dragged around. And then the position is what actually stores where the overall general translation of this is, and so we're just going to create a new point, and that's going to set it to 0. The scale, that is how far zoomed in or out we are. I just have that set to 2 by default. The LBD is left button down, which we're going to assume it's not. Control is down, not. Shift isn't. Shift down, not. Then we have selected port comp ID, selected port pause, and selected port ID. So in the components, what we have is we have a series of ports on them, and that's these actual little bits on the end, and you can see that a little marker comes up, and that's the selected port essentially. So it will store the ID is going to be the component ID, because all components are allocated an ID. The position is going to be the position that it is. It's either on screen or in the place which is, or in the coordinate system for where the actual components are located. And then the ID is a string identifier assigned to each port. TLDC and BRDC are the top right corner and bottom, or the top left corner and the bottom right corner of this. So we're gonna have the top left corner and bottom right corner. Mouse drag start. So when we drag the mouse and create this box, we're gonna store the position where it starts so that we can draw this rectangle. The mouse position is just going to store the current mouse position so that we can use it anywhere in the code. Show line. So when we're creating connections between components, I have this bit in the middle, which I just call a line, even though it's this weird squiggle shape. And so if it's on, we'll use the selected port position along with the current mouse position in order to draw this line in. Then line pxmov is going to store in here. We can move this bit of the line by holding control and scrolling, and so that will store this when actually rendering this in progress line. And then line start x, so lines can either be drawn going along the x-axis or along the y-axis like this, and so this will store in which way it wants to do that. Next up, line start component ID is going to be line start component ID and line start port ID are the variables which are used when actually getting the coordinates of this port here that we used to draw the line. Lines and comps show the lines store the lines and components which are actually part of the frame and not something that we're currently editing. Then clipboard comps and clipboard lines is the same thing, but you can copy and paste these things and it will do that. So then we have in the constructor where we're also adding the file, where we're loading from a file, what we'll then do is we'll create an object stream for the file so that we can just read and write Java objects without having to worry about custom serialization code to convert the objects into bytes that we can write to the file. And we'll just so the streams will do that for us. And so what we'll do is we'll read in a collection of components and a collection of lines and just add those to the components and lines which are in the frame. And then we also have this force load method, which is going to go through and it is going to forcefully load all of the components into the frame, and I'll go through all of this code in detail later. But it will go and register all of the IDs for all of these components and ensure they're all set up correctly. Next up, we have a series of toFrame chords and fromFrame chords functions, and what these do is all of the components are stored in the frame in their own coordinate space, and then when they are rendered, what we instead use are frame coordinates, which are the actual coordinates in the frame, which deal with dragging around and zooming in and zooming out. So then what that does is we'll just create a point, we'll copy the point that we get in for a point, we will translate it by the position, and then we will return a point which is half the width plus half the width, which will center it, which will center 0 on the screen, plus the point's location multiplied by scale, which will actually zoom it. And then because this is in pixels now, we have to keep it in ints and not decimal numbers. So continuing, we also have a function which does essentially the same thing on all 4 points of the rectangle, and then we have inverse functions which can grab points and rectangles which are in the frame's coordinate system and convert them into the component coordinate system. Then we have get and set selected component, which just retrieves the component which is currently selected, by the user. And then we also have a function which is just going to check if a specified component collides with the mouse position. And Java is nice, so what we can do is we can just take the component, and there's a getBounds function that it has, convert it into the frame's coordinate system and check if the mouse position is contained within that. And then we also have add component to selection, which is going to, when you have 2 components on the screen, you can select one and then you can add another one and then have them both selected. And so this will do that, and the main thing that it has to do is update the corners for the selection rectangle. So what we'll first do is we'll convert the component's position into the frame's coordinate system. Then if the dragged components array is currently empty, then that will make this the only component. So we will get the component's position, which is going to be its top left corner, and make that the top left corner of the selection rectangle. We will translate it by we will translate that point down and to the right by the component's width and height, and then that will be the bottom right corner of the rectangle. However, if it's not empty, that means we already have at least one component selected. And so we're going to essentially do the same thing, but we're going to ensure this time that the top left corners x and y are always going to be the lowest between the two components, and the bottom right corners x and y are always going to be the higher number between the two components. And so then the rest of the code is basically the same as up here. Then if the dragged components if the dragged components does not currently contain the component, and we are not passing in this abort add, which I don't currently remember why it's here, but that's why we're going through the code now. But if abort add is true, then this will evaluate to false, and then we'll have updated the points, but we won't have actually added the component to the list of stuff which is dragged. And now we have the paint function, and this is what actually does the rendering into the frame. And so what we do here is we start by creating an image with the size of the frame, and so this will allow us to draw on the image and then call a single function to draw the entire image onto the frame, and otherwise you get a flickering, and so this is called using a double buffer. So we buffer our entire render onto this image, and then we draw the image in a single operation rather than going through and doing each of these steps on the actual frame. So we start by getting the graphics object on the image, which is what will actually allow us to draw. We're going to set the color that we're drawing into black, and then if GUI.shouldShowGrid, which will just get whether the show grid box is checked, so that's this one here. Then if the scale is greater than 0.4, and I do this because otherwise, if you zoom out really far, then you essentially just get too many dots to see anything, and it takes too long to actually draw them to get a smooth experience. And so if either of those things are not true, then we won't actually end up drawing anything. Otherwise, we will iterate through all the x and y coordinates on the frame, and just for this function, the dots don't actually symbolize any coordinates, and so we can be somewhat lazy with this and just say if the x translated by the position times scale is modulo is divisible by 20 times scale, and same thing with y, then so at every xy coordinate, which when translated is a multiple of 20 pixels times the scale, then we're going to just draw a 2x2 a circle of radius 2 at that point, and that makes a fairly nice grid here, which you can see zooms as you scroll. Next up, for each component in components, we're going to see if the component's bounds intersects the bounds of the frame. So if the component is on screen, then we're going to convert the component's position to frame coordinates and then draw the component's image, which it provides to us at that position, convert it along with its width and height multiplied by the scale so that they zoom in and out as we scroll. Next up, we'll set the color to, and this is the kind of teal color that's used for selections. and then if you're holding Shift and the left mouse button, then we're going to draw a rectangle from, then we're going to draw a rectangle from wherever you started dragging to wherever you currently are. So if I am holding down Shift and the left mouse button, then it will draw that rectangle in. And then otherwise, if you have some components on frame and or selected and you're not dragging this, then we can draw a rectangle. Then we're going to draw a rectangle between the top left and bottom right corners. And specifically, if you look at this function rectangle from any corners, so rectangle from corners just passes in the top left and then calculates the differences between to the bottom right position and uses that. To get a rectangle from any two corners, which is what's done for the general mouse position, what you have to do is you take the minimum of the two x's and the minimum of the y's, and then the maximum of the x's and the maximum of the y's, and you use those 2 points as being the top left and bottom right, and then we just pass that to our other rectangle from corners function. Then back here, next we're going to set the color to green, and then if we currently have a port selected, then we'll convert its position into frame coordinates and draw a 2x2 rectangle there. So if we have a port on frame, that just draws this little lip here, which isn't that obvious, but it helps you to identify kind of what you're selecting. Next up, we're going to set the color back to black, and we're going to set the stroke size. So this means that when we draw lines, this is going to be how thick the lines are, to twice the scale, which just means that when we scroll in and out, it will adjust the width of the lines to match. And then if we are showing, we have show line true, so we are currently, start this twice. So if we are currently drawing a line, then show line will be true. Then convert the line start position into the frame coordinate system, and then draw a line between that and using all the variables that and then using the mouse position, whether the line is horizontal or vertical, and the width that it's moving, and the move percentage, which is just the percentage that the line is, that this bend in the line is along the length of the line. So what we do is this version of the function essentially just unpacks the points into their coordinates and then passes them on to this move line function, because each of these lines actually consists of 3 different line segments. So we have this line length, which is just going to calculate essentially in whichever x or y direction you move, it will calculate this percentage along the line, and it will make sure to do that in the correct direction. So i.e. if you have a line going to the left, it will do it in the opposite direction than if you're going to the right. And that's what this copy sign will do. It copies the difference of the x's into that. And then we are going to draw the line from the starting position, x and y, to this line length distance along, and at the same y. And then from that place, we're going to go along the y-axis and then back along the x-axis to the endpoint, and then the same thing, but on the other axis for vertical line. Next, for every line which is not what we're currently drawing, we're going to draw a line, call that same draw line function, and then the lines, rather than, in order to make sure that when we have two components which have a line between them, that we can move one around and the line will move with it, rather than storing the actual coordinates of the line's position. We just store which components they're connected to. And so we're going to retrieve the component with the line's component ID, and specifically on that, the point with that port ID. And then we're going to get that and convert that into frame coordinates. And then we're also going to do the same thing for the line's endpoint. And then the rest of the information used is stored as part of the line object. Finally, we are going to dispose the graphics object, which doesn't actually delete everything we've written. It just cleans all the resources which were being used for it. And then finally, we're going to draw this image that we've been rendering onto the actual frame at position 0. And it also requires an image observer, but because we aren't using that, we can just pass in null. Alright, so next up, what we have is a bunch of functions which receive all of these events that we signed up for earlier. Sorry, up here. And so these will handle all of those events. So when a component is added to the GUI frame, then if it's this component, then that means that we're actually in the frame. And what we can do is we can request focus, and I believe this is provided by Java. So we'll then request focus so that we can actually receive all of these events. And then if we are removed from the frame, then we're going to go and remove all of our listeners for those events, and delete the selection window. So the component selector that we had earlier, we're going to delete that window, and then also clear out all of the components and lines that we had. Next up, we're going to check when a key is typed, so pressed and released. If it is 0, then that will just reset the translation and scaling. So we're going to set the location of our position to 0 and the scale back to 2. If you press R and you have exactly one component selected, so if I have a single component selected and I press R, it will rotate it. And so what this does is it will get that component, and it will just call a rotate function, and then update, and then call the appropriate code to update the selection box. And rotate just works by incrementing its internal counter of its rotation, resetting if we go over 4, so that we're always either at 0, 1, 2, or 3. And then adjusting its position in order to make sure that it stays centered. Then, sorry, 1 second. Oh, and then it also has to go through and it keeps a list of all of its ports that it has, and this will go through and rotate them to the different arrays, so that L inputs only contains the ones on the left side, top, right, and bottom, and it will just rotate, and utils has a function which will go and rotate them between these. So if we have at least 2 elements in here, then for each one we're just going to, we have 2 buffer maps in here. So we're going to clear the second one and put everything from the first one in the second one. So if you can imagine, if we have 2 maps, which are just going to for now have, say, for this case we can just imagine them as lists, so though they're actually maps. But we can say we have one with 0 and 1 in it, and one with 2 and 3, and then we're going to have our buffer 1 and our buffer 2. So you can see first what we do is we clear buffer 2, then we're going to put all of buffer 1 into buffer 2, then we're going to put all of buffer, then we're going to put all of whichever map we have selected, which in this case is going to be the first one, so into buffer 1. So buffer 1 is going to gain 0, 1. Then we're going to clear 1 and 1 second. All right, sorry, I'm back. So we're then going to clear map and put all of buffer 2 into map, which is this. And then next we're going to iterate the second time. This time we're going to have this map selected. So we're going to get buffer 2 and clear it. We're then going to put all of buffer 1 into buffer 2 and clear buffer 1. Then we're going to clear this. Then we're going to put all of the currently selected map into buffer 1, and we're going to put all of buffer 2 into the selected map. And then finally, what we do at the end is we're going to finish by grabbing the first map and putting all of buffer 1 into that. And what this ensures is that we'll essentially, if we have 0, 1, 0, 1, and then 2, 3, 4, 5, 6, 7, we will end up with this is the output. And this will just go and cycle them around. But because Java is passing all of these maps by reference, we can't just use equals to set all the maps to each other, but we instead use these functions to put all the elements into each map and cycle them around. So then we get into key pressed, which is going to be when someone just presses down a key. And what we do is we get the key code of the key, and we can check. And this is different because, for example, if you press down Control or Shift, then there's no character associated with that, and so it allows us to get using key codes, which does have this ability. So some of these are simple. So starting out with Control and Shift, if either of those are pressed, we're just going to set whether Control or Shift is pressed to true, so that we can use that elsewhere in our code. If you press the delete key, then for every component in your dragged components, then we're going to create an array list of lines that we have to remove, which is going to be the connections between all of those components you have selected. And then for all the lines which are in the frame, we're going to call stream, which will give us a stream object that we can do some cool functions on. And we're going to filter that down to just components in which either component ID 1 or component ID 2 is the component we're removing. And then for each of those, we are going to free those ports, because Resource Manager, along with keeping track of IDs, will also keep track of all the different ports. And actually, at the end of this, I'll go over exactly how Resource Manager works. And then remove lines, and then we're going to add that line to the list of lines that we have removed. And essentially what that's going to do is it's going to remove all. And so you might be saying, why don't we just do lines.remove elm? Mainly because you can't remove an element from a list that you're iterating over. And so because we're currently iterating over this, what we'll do is we store them for later and then remove them here. And then we're going to remove this component from comps. Finally, we'll then clear out the drag components because they've all been deleted. Now I said I'd go over how Resource Manager works. This is So essentially what Resource Manager does is it keeps track of all of the IDs of components which are existent, as well as images and all of the ports which are occupied on all components. And so it just keeps track of all of this, all of these resources, and it makes sure that only certain people, that you can only access them in ways that you should be able to. So what we have here is we have a list of images. We have a list of images which maps alias to images, and I already went over how that works. Then we have a list of integers mapping to components, and in the future I should make these longs so that we can store 2 to the 30 or 2 to the 64 minus 1 because I'm only using positive for the moment. Ideally, eventually we'd be able to store all 2 to the 64 possible longs in here, or 2 to the 64 minus 1 because I'm using -1 to mean null, but in any case, for the moment, we have a list mapping integers to references to components, and essentially what this means is that Java employs a referencing system whereby when you have an object, rather than actually, when you pass an object, say, to a function, rather than actually passing this object, what you're actually passing is essentially a reference, and then when the code wants to go and do something on this reference, it will go and unpack this and get the object from it. But you're only passing around this reference, and what that means is that in here, those are normally strong references, which means as long as an object has at least one strong reference to it, it cannot be deleted, and it will always stay in memory. But as soon as it loses all of these strong references, then Java can delete it in order to free up memory. And what this will do is we store weak references, which is explicitly saying, which is a specific object type, which does maintain a reference to the object, but it doesn't flag it as a strong reference, which means the object can still be deleted, and then we can read that, and that allows us to free up component IDs by deleting objects while still having references, while still keeping a reference to it here. We can check if all other references have been deleted, basically. Then we have a map which will map integers of, I believe, these are the same component IDs to a list of all of the ports on there which are occupied, I think. Figure that out as we continue through this code. And then we also have a series of component ID lock. We also have a component ID lock which protects access to this map to make sure that 2 threads don't try to edit it simultaneously, and a port lock which makes sure that two threads don't try to edit this ports map simultaneously. And finally, we have a cleaner here which will allow us to detect when these references are freed, and state key, I have to figure out what this does again. Yeah. Okay. I'll figure out what that does. So, essentially, what we're going to do is, let's just go through. So, first we have this add as new function, which is called by here. So this is called to add in components copied from clipboard, and so it's going to take in the input number of components, input lines, and the center that we want to center all of these on, the point that we want to center all of these on, and then an array list where we want to put the output, the new components into, and the new lines into, and the component which is the window which is rendering all of this. And that's just used to display an error message. So first of all, if there are no components we're adding, then just exit at the function and don't do anything. Next up, for new components, we're going to take all of the input components. We're going to stream them, and we're going to just call this collect function, which allows us to take the component, and for each component in the stream, we're going to add it to a new map, which is going to map the component to its IDE. And save copy is just a function which is going to so save copy is what's actually going to copy this. And essentially what we're going to say here is DComponent. We're going to create a new component, which is going to be this class, and we're going to assume that we have a constructor which takes in a point, and we're going to create a new instance of it, passing in this component. So what this does is it uses Java reflection. So say if we have a buffer object, this would be the same as saying comp equals new buffer pause. But it means that because this is in DComponent, we don't know if this is a buffer or a AND gate or some other component that I haven't added yet. And so this will just work in any case. Then because this doesn't allow us to pass in rotation, we are going to make sure that it has the same rotation that we do. So just by calling rotate however many times we've been rotated. And then we are going to then return it. And essentially if we get any error, then we're just going to wrap that into a reflective operation exception. And then finally here, what we have is a save copy is just going to call this copy method, but if it receives an error, we're going to call this underscore throws. And what this does, if I remember correctly, is it's going to keep a log of all the errors that we receive. So essentially, if we receive oops, I did not mean to close that. In here, normally copy has the ability to throw that exception, but if any exception occurs in here, but we aren't allowed to have any exceptions occur in here because the specification for this says that they can't throw any exceptions. And so what we do instead is we'll just log it into utils errors here. And then when we've done all the copying, what we'll do afterwards is we'll check to see if any occurred. And if something has occurred, then clear all the errors, say that an error occurred, and then don't continue adding them, because at this point we've only copied them, we haven't actually added them to the frame, and so we can just say that an error occurred and leave it there. Then and also if the components are programmed correctly, this shouldn't happen. So the only way that would occur is if something went wrong in the initialization of components, which isn't supposed to happen. So in any case, so then we're going to retrieve the first component, and essentially what this does is we're going to we're just going to use that to initialize the corners, and we're going to essentially do all of that math that we did before to calculate the top left and bottom right corners for a collection of components, but given the components that we've been passed in. And so we're going to do all of that math and essentially end up with a top left corner and a bottom right corner. And then what we're going to do next is we're going to convert those corners into a rectangle, and then essentially find the we're going to then find let's see here. We're going to then center it and essentially go through and use it to adjust the positions of all of the components we've created to center themselves on this center point. Then we're creating an ID map, which is going to be used by taking the components we've created, and streaming the entry set, which is just going to be the collection of all of the entries. So the entry is going to be a class which is going to contain the component and the ID. And what we're going to do with that is we're going to turn that into a new map, which is going to map the value, so these IDs here, to the components that we have here. So what that means is we are essentially creating a map of the old component IDs to the new component IDs. Next, before I continue, this was just bugging me for a second, but if we access this part here, then you might question that the components we create here have already had their IDs registered with the Resource Manager, and we'll get into how that works down here. But essentially, and that would cause them to be locked up even when this code is run. But no, because after this bit, we'll be freeing the references to those components, and so this code down here is set up to detect that, and it will free all the IDs. Sorry, that was bugging me. So next up, we're going to get the input lines, and for all the lines that were passed in, we're going to ignore them if the map that we have here does not contain both components. So if we have not copied both components, then we are not going to try to create a line. So you can imagine if we have three components like this, and we just connect them like so. Then if we go and copy these two, it will copy this line between them, it will copy this connection between them, but it won't attempt to connect this component up to here because we haven't copied that and it's already in use. So if either of those are existent, then we're going to just remove it. Next up, new lines. So we're going to create our new lines, which is going to be all of the lines that we're creating, because the old lines were the connections between the old components, and now we need the connections between the new components. So we are going to take the input lines, and we're going to do map, which is going to convert each element in this list of input lines to a new element. And essentially we're just going to go one element at a time. So we're going to take the old component ID and map it to the new one using this map we create up here. And the port ID is going to stay the same with the second component and the second port, and the rest of the line information is going to be the same. And then we're going to collect that into a list, and that'll be our new lines. Next up, for each of those, we're going to call reserve port, which again I'll get into, but essentially it will mark the ports on these components that the lines use as being in use by the lines, so that we can read that later and not try to connect two things to the same point. And then finally, all we do is the output components are going to be added. We're going to add all the new components to the output components and all the new lines into the output lines. All right. Next up, we have force load, which is going to be when we're loading from a file. This is going to say ignore all of other kind of things that exist. Just this is saying that we are loading from a file, and we want to ignore all the normal stuff that we'd have to do in order to check that stuff is reserved and open and nonsense, and just mark all of this stuff as being registered. So we're going to set the component. We're going to lock the component and port arrays so that no one else can edit them. We're going to update the state key, which I'm guessing, based on my read of this code, is is going to be something which means that I believe if one of the components is deallocated, we normally get a notification, and again, I'll go into that later. But this makes sure that if we have a component which is deallocated because we are deleting all the old components, that we then don't try and remove the new component with the same ID. So in any case, then we're going to have the state key is going to be a new object. We're going to clear out the old components imports if we had any. And then essentially we're just going to, for every component we have, we're going to get the components and register its ID to map to a reference to the component. And for all the lines, we're going to reserve all of those ports. And then at the end, finally, we'll just make sure that we unlock both of these locks we have earlier so other people can access these arrays. Next up, we have alloc ID. And what this is going to do is it's going to whenever we create a new component, we want to allocate an ID for it. And so this is going to go through, find a blank ID, and add it. So we're going to lock the component ID lock so that we can have access to the component ID array. And then for every integer in 0 to 2 to the 31 minus 1, if the component IDs have the key, if the component IDs does not have that as a key, so if that is a free ID, then we're going to save that as that component's ID with a reference to the component, and we're going to call cleaner.register comp dalloc ID runner with this. So what this will do is cleaner.register is going to register something to be run when this component loses all of its strong references. So essentially when the only references to it are stuff like this where we only want to keep it around until it's no longer needed by anything else. So when we're the only people who care about this component, then we're going to have dalloc ID runner, which is going to keep the component's ID and state, and as well as the current state key, so that if we try to reload anything, we don't get that case where it attempts to delete a component that was already deleted by us. And it's going to save those as part of the object, and essentially if the component is ever loses all of its strong references, then we're going to call a function which will deallocate its ID. Next up, get component based off of the ID is going to lock the lock for the component ID lock. And you can see we have read lock here as opposed to write lock. The difference is that we're using a read-write lock, and so with that, what that means is that multiple threads can hold a read lock, but only one thread can hold a write lock. So only one thread can write to this array at a time, but multiple can read from it. And so we're going to do get component based off of the ID, and if the component IDs if that ID exists, then return the element, otherwise return null. Next up, we're going to have the ability to reserve the ports for a line. So on the component, we only want one line to be able to connect to each of the different connectors on it. So that's going to just call that's going to reserve the port on both ends of the line given the component ID and the port ID. And this just calls this will lock the port lock, and if the ports contains if the ports contains a key for that component, then if the port is registered, then throw an error. Otherwise, if there's not currently a list of ports which are locked on that component set up, then create one, and in any case, if it's not in use, add that port as being in use. Next up, we have free port, which is going to be when one of the lines is disconnected, and it is just going to get the write lock and if the ports for this component has been set up, then clear that port as from being in use. Then we also have port status, which is going to check whether something is connected to a specific port, which is going to lock the read lock, and then if ports for that object has been set up, so at least one port has at some point been locked, then check if it contains that port ID. Otherwise, if it doesn't contain this, then no port has ever been used, so just return false and then unlock. Finally, we have here the function which will deallocate an ID for an object. Notice how this is private, so it can only be run by this function here so this means that some other piece of code won't accidentally call that and deallocate the ID for an object which is still in use somewhere. So then we have the state key is going to be so if the state key is different, so every time we like load from a file or something, we'll update the state key, which means that we will never have a state, which means that if any of these tries to change this, the state key will have changed, and this will not be equal, and so we'll just exit the method. Otherwise, lock the component lock and remove all of the component IDs, and lock the port lock and remove the port IDs. Yeah, so remove the ID from component, and then remove any ports which were assigned to that component as well. All right. Now, while we're on the subject of going over other sections of this code, I know I'm doing this in a weird order, then figured we might as well go through how decomponents work as well. So the base for a component contains three things to create itself. It needs a name, a size, and a position. So when we create a component, we're just going to allocate an ID for it, save the size, keep the position. Notice how we do pos.x and pos.y. This means that because Java again passes by reference, if we had just said pos equals pos, then changing the coordinates of this point would then change the actual position, and this ensures that it stays as part of the component. The rotation is going to be 0. We haven't rotated at all. And then the actual inputs are stuff which will be set up by subclasses, and so we'll just initialize all of these to be empty arrays. So next up, we already went over how the copy method works and rotate, and then we just have a few methods which will get the rotation. GetImage is going to return the image of the image name plus rotation times 90. So we'll get, so say the image name is test, then if we rotate 0 degrees, then it'll be test 0, 90 degrees, test 90, etc. And yeah, this is different from just getting the image and then rotating it each time, because otherwise every time you wanted the image, if you have 10 components which are all rotated 3 times, then that's rotating 10 images 3 times each, which is 30 different image rotations each time you want to render the frame. And so we just cache them all when they're read in, and then we only have to do it once when the program loads up. Next we have intPoint, which is going to return the position as a point using, the point is actually stored using point2d, which stores as doubles, so that we can get finer movement. But if we want, we can call .intPoint, which will return the point with the integers being truncated, so it will just be, so for example 1.5 by 1.5 becomes 1,1. And so we just remove that decimal precision. Next up, we have getBounds, which is just going to return a rectangle based on the point based on its location and size. So we'll get the integer position and use the size, which was passed in when it was created. And then finally we have get points, which is just going to return all of the different input things in these input arrays and their locations. So we're going to have this will return tagged points, which is just a point which is going to have a name associated with it. So it'll be a location and a name. And so what we'll do is for each one of these arrays, we're going to get its entry set stream and convert it into a tagged point, which is going to have which in this case isn't actually specifying a position, but rather a pair of numbers. Yeah. And so these are mapping the port IDs into integers, which is how far along the object they are. So for example, for buffer, I believe this is 50 pixels. So this point here is, I believe, at 25 down. And so it is called like input 125. And so that's what all of those store. And then what we're going to do is we're going to create a point, which is the position in this time, specifically this component's coordinates. So for things on the left, their x is going to be 0, and their y value is going to be whatever that number in the map is, and the name of it is just going to be the key. And we're going to do all of that and turn it into a list, and then same thing, we just calculate all of those positions and store them. And then finally what we do is because we obviously aren't in we don't really have a use for those coordinates, which are based on the top of the component on this position here being 0, 0, but rather something which is at least in component coordinate space. We're then going to translate those all by points by whatever our component position is. And then finally we have a get point for the ID, which is going to do get points and just filter it down to the ones which are to whichever points have that ID, and then just pick any of them. If you're programming components correctly, they should all be unique IDs, so this should only return 1. And then, or else and so this is going to give some element, which is going to be, it doesn't matter which one, as I said, it should only be 1. And if we don't find one, then we're just going to throw an exception and say that you're searching for something which doesn't exist. So I believe that's off with the tangent of how Resource Manager works. So, alright, I believe we were at escape next. So, as I said, I'm sorry for jumping around so much, but continuing. If you press escape, then stop showing lines. So if you're attempting to draw a line, you can just press escape and it will stop doing that. If you press Control C, then clear out anything that we have in the clipboard. And if you have something selected, then add all of the components that we have selected into the clipboard. And in order to get the lines, we're going to say we're going to add just every single line that we have. And then what we're going to do is we're going to get the clipboard components, and this is a list of components, and we're going to instead map it to the component IDs and collect those into a list so that we have a list of all of the IDs of components which are in here. And then if any of the lines contains a component ID which is not in the clipboard, then remove it so that we only get lines which are connect these components. And then finally, if you press Control V, we're going to create an array list for new components, and we're going to call that addIsNew function with everything that we have in the clipboard, centering on the mouse position, we're going to store it in new component. We're going to store all the components in new components. We're going to store all of the new lines that we get just in lines, and then this is the this is the component that we want to center on if an error occurs. Next up, we're going to clear out any components that we have selected, and for every single component that's new, we're going to add it to the list of selected components, and then we are going to we're going to add all of the new components into the list of components. And then finally, we just have something here for key release, which just makes sure that if you release Control or Shift, we set those variables to false. Next up, if a mouse is clicked, then we're going to say if not if you have a component selected, and so if you have a component selected and you're holding Control, if you're doing that, so wait, sorry, I've got myself confused now. If you do not have a component selected and you're holding Control, then we'll do nothing. So if you're not holding Shift, then we aren't doing anything, and if the selected port ID and if we have something selected, then we are not going to do anything if the mouse is clicked. I would explain in more detail, but as I said, I haven't looked at this for a few months, so I've somewhat forgotten exactly how this statement fits into the rest of the code. But I believe this is going to attempt to create a line, so what we want to do is I believe we don't want to create a line if we have a component selected, if we are holding Shift, if we have a component selected, if we are holding Shift, or we aren't within range of being able to, or if we don't have a selected port, so if we don't have any of these little green dots that show where we're a port that we're close to, if we don't have any of those things, then we will not attempt to create a line. If we do, then if the port which we have selected is occupied by another line, then just return and don't do anything. Otherwise, that means that we want to attempt to create a line on this component, so we're going to clear out anything that we have that we're dragging. We're going to set the start location of the line to the selected port position, line px mov, so the point at which we want to bend the line, we're just going to set to be halfway along it. The component that we want to create the line on, we're just going to retrieve the selected port component ID, and the position of that component, or the position of this port, it looks like, 1 second. Okay, I've looked at this for a few minutes now. I'm going to say that I don't actually remember what exactly this code is doing outside being able to read what it does. But in any case, what this will do is, in some math that I'm pretty sure I worked out once and then forgot, we will calculate whether the line is going to be a horizontal or vertical line based on whether it is selecting a point which is on the left or right inputs. Then we will save all of, and then we will save all of the selected port IDs, component IDs into the line start location and say that we are starting to create a line. Next up, if we just have a mouse button pressed but not released as opposed to clicked here, then we can set if e.getButton is not 1, so if we have not pressed left click, then as you can see, I have some code that I'm pretty sure I was planning on building out here, which is if we've instead right clicked and we have a component selected, so my guess is I was going to implement a property menu of some sort, then if the mouse is pressed, set the left button down to be true, set mouse drag start to be the current location, so if we try moving the mouse around, then we're going to have that, then we're going to know where the drag start was, and then mouse in rect is going to be, so if we have some number of components which are being dragged, and within that rectangle created from the and if the mouse click is within the rectangle which is created by those two corners, so is within the rectangle of the drag components, then we'll store that in mouse in rect, which it looks like we use later. Then we shall if not control and get selected component is not null. So if we are pressing control and we have a component, we have a component select, so I believe this is the same condition as it's not, sorry. If we are not clicking within the rectangle and we are not pressing control in order to, so I think it's going to be easier if I do this. So if we have some number of components selected, that can be 1 or 2. If we are clicking within the rectangle, we want to move it around. If we are clicking out of the rectangle, we want to delete the rectangle. And if we hold control and click another component, we want to add that to the rectangle. So if we are not holding control to select a new component, and we are not pressing shift in order to I believe you can I'm not sure why I put that there. But if you're not pressing shift and the mouse is outside of the rectangle, then we're going to clear out all of the dragged components. Oh wait, maybe so that's what I did. So if you have a series of components selected, what you can do is if you continue to hold shift, then you can draw another rectangle around other components and it will add them to the selection as well. So in any case, if we aren't doing any of those things and we've just decided to click outside of the rectangle, then we are going to clear the dragged components. Otherwise, if we are currently drawing a line, then if we don't have a port selected, or the port status of the port we have selected is in use, then what we want to do is we want to create a line, I believe. Yeah, and so what we're going to do is we are going to get the coordinates of wherever we've clicked, and we are going to see if we are going to end facing vertically or horizontally, and I mean, at first glance, it seems like, well, if you started horizontally, you're going to end horizontally. But this changes if we take this to being 100%, because in that case, you can see we're instead vertical. So we want to end vertically, as opposed to ending horizontally like we normally would. And so we just add a condition here. So if we are at 100%, then invert whether we started on X, or whether it's a horizontal line, and then otherwise it's going to be whatever we started as. So next up, we are going to create a new junction component, which is just going to be something which will allow you to take one line and split it off into multiple. We are going to set its location to be essentially some bit of code, which I believe is going to calculate it so that the port position is at wherever you've clicked. And this does it by using both whether you're ending on a horizontal or vertical component, and then also whether you one second. All right, sorry, I'm back. And also the size of the component in order to determine, given where you've clicked, where it has to place the component in order to ensure the port that it will be connecting to is at wherever you've clicked. Then we're going to add that as a component, and the port, you can see that on the junction the port names are P1, P2, P3, and P4, and so we're just going to check based on whichever port you have selected whether we're going to be, so if you're horizontal, then you're either going to be 0.2 or 0.3, it appears, and so then given whichever one is, so if the line start position is less than the end position, then that means that you will have moved to the right, and so we know that P2 is probably going to be the left port, then P3 is going to be right, and then similar logic for the Ys. Next, we're going to reserve both of those ports using Resource Manager, and then using all of that information, we're going to add a new line, and then show line is false because we have completed adding that line. Otherwise, if we are showing a line but this condition has evaluated the other way, which means that there is a port that we have selected that we can connect to, then reserve both the port we have selected and the port at which we started, add the line, and show line, and stop attempting to create the line. Otherwise, if we are not showing a line, if you have a component selected, then that means that you either are holding Control or Shift, or if you're either holding Control to add it or you're clicking on the first component. In any case, we want to add the component to the selection. However, we are aborting if the mouse is within rect. So, what's the behavior generated by this? So my guess is that means that if you have like this, so it means that you can't. So what this means is that it will stop, it won't actually add the component if it means that you can click in any selection that you've drawn, but it won't actually add the component that you have on the inside, I guess. And that's what the abort flag was for earlier. So next we have get and reset. So otherwise, that means that you have done nothing but click somewhere blank on the frame where you don't have a component that you're clicking on and you're not editing a selection of some sort. And if that's happening, then what you want to do is you are going to get the component that we have from selector, so whichever one of these components we have selected, and we are going to and if it is not null, so if we have like none selected, then it will return null. And so essentially, if none is not selected, then add that component to the frame. Now on mouse released, so if you've let go of button 1 of the left mouse button, then set left button down to false, and if you're holding shift, then create a selection from wherever you started dragging the mouse to wherever you are, and for every component that you have, if it intersects that selection, then add it to the selection. So if you have 2 components, if you're holding shift, and when I let go of button 1, shift is down, and so it will go and it will take this corner here and this corner here and add all components which intersect this selection, which is those 2. Yeah. So, next up, on mouse dragged. So when we're holding down left click and we move the mouse, which is dragging it, we're going to call the mouse. We're going to call mouse moved because I believe it doesn't fire mouse dragged and mouse moved events, but we still want to be notified of mouse moved, and so we're going to call that function ourselves. And then if we are not holding down left mouse button or shift, so if we are dragging a button which is not the left mouse button, so like we're dragging right click, or we are holding down shift, so we're creating a rectangle, then then calculate the difference in x and difference in y between wherever we started dragging and wherever our current position is, and divide those by scale, which will convert them into the dx and the delta x and delta y, not in frame coordinates, but in the component coordinate system. And then if we don't have any components which we are dragging, then we are going to update the position by that dx and dy. So that's what so that will just drag the frame. And then otherwise, translate the top left corner, the bottom right corner, and the dragged components all by that number, all by that amount. You can notice that these are using the frame coordinate ones and these are using the component coordinate ones because those are the 2 systems they're in, and that means that we can drag these around. And then next up, we're then going to say that the next time the mouse is dragged, its location for that mouse drag is going to be ending off wherever this one was. So if you drag the mouse like that, that isn't one event, but rather a bunch of individual small events. And so this means that we don't get a cumulative effect of a drag, so that the first event isn't this, and then the second event is this whole distance, but rather the first event would be this, and then this distance would be the second event because we've already accounted for that first difference. Almost finally, we have mouse moved, which is just going to update the mouse position variable, and then it also means that we are going to first of all set the selected component to null, but then for every component, essentially just find one of the components that intersects with the mouse position and set it to be the selected component. Then, in a similar manner, we're going to clear the selected port component ID by just saying it to -1. And that's the value that the code checks for to see if it's -1, then that means nothing's selected. We are going to have the distance, so we want to find the closest one. So for the moment, we're going to set distance to be the max value. And then we're going to say for each component, if the component is on screen, then get all of those port positions for the component, and then from that we are going to convert those positions into frame coordinates and get the distance to wherever the mouse cursor is. And if that distance is less than 12, I believe that's pixels. So if we're within 12 pixels of the port, and that distance is less than whatever the current distance is, so that we always get the closest one, then update the selected port information to match that port that's the closest, and also update distance, so that in further iterations of the loop we will have the closest distance. Next, mouse wheel moved. So when you scroll the mouse, we're going to get an event, and if we are currently holding down Control and drawing a line, then we're going to take line px move, and we just have this constant, which is saying that we're going to move by 5% along the line each time we scroll, or each 1 unit of scroll distance. And so then we will move the line px by that amount, and then if we're less than 0, set it to 0, and if we're greater than 1, set it to 1, and that makes sure that we don't get a case where we move past our endpoint. Otherwise, if we are not currently showing a line, then we're going to try to scale it. So we're going to store whatever the old scale was, so whatever our current scale is, and then we're going to take the units that we scrolled and multiply it by negative 0.1, which is going to mean that which is just going to convert that into the amount that we want to adjust the scale by, use that to update the scale, and then if the scale goes out of those scale min and scale max bounds, then cap it to those. Next, if the scale has changed, which it should have, and the drag components is not empty, so we are dragging some components and the scale has changed, then then we are going to go through and recalculate these top and bottom position points, because now all the components will have moved their on-screen positions because we've rescaled the frame. And now, finally, for this file, we're going to have a save function, which is just going to take a file, create an output stream for it, and write the components and lines to that file. I don't know why I closed everything. Now, I believe in here, so now we can go back and see and look again at this close content panel. So we have save unsaved, which when we try to close it, it will attempt to save if we have that panel open. So it will ask if we want to save changes, and it'll give us the options to save, discard, or cancel. If we select save, then it will call save. If we select discard, then return true, so say the user has approved that you can now close the window. And if the user just closes the pop-up or selects cancel, then say the user has not allowed you to close the window, and then it will relay that up to the code which is attempting to close the window or the pane. If the user selects save, then we're going to call the save function, which is going to say if we have the ability to save, then, or if we don't have the ability to save, then just say, yeah, we saved it, but there was nothing to save, so it doesn't actually have to do anything. Otherwise, if the file name, if we have a file name that we have opened, then if the user has just pressed save, then save it to that file. Otherwise, ask what the user would like to save it to. And same thing with that, save as, return true. Then we're going to create a file chooser, which is going to select logic map files using the same settings that we talked about before. And then show the file. If the user just closes the dialog, then return false and say the user canceled this operation, so don't close anything. Otherwise, try to save as that file. Next up, in either case, we'll eventually get a file. If we passed in the file name as up here, then it'll just convert that to a file. And now we're going to try to save to that file. So if the file exists and we're going to overwrite it, then we're going to show a warning, say, do you wish to overwrite this file? And if they either select no or just close the panel, then we will interpret that as them having canceled it. And so we're going to say return false, which means the user canceled this operation. Otherwise, if the file does not exist, we're going to create it. We're going to set the file name to be whatever the file's path whatever the path to the file is, and then we're going to call that save function, which is going to actually write the components and lines to the file so that we can load it later, and then return true. We successfully saved the file. And I believe the only thing left to go over is the specifics of these components, but these are fairly simple. So essentially, when the class is loaded, then we are going to attempt to load in the images for whatever the component is. So for the buffer component, we're going to load the images, the image asset / buffer.png with the alias buffer, and print any errors that occur while doing that. And then in the constructor, you can see that we also register our inputs. So in the left inputs, we put one called I at position 24, and in the right inputs, we put O at position 24. And those correspond to those locations in the images. And you can see all of these other ones follow a similar model, and they have a dimension which represents the image sizes, in most cases 100 by 50. And specifically, let me pause the stream and open something up. Okay, so this is the window where we have these files, and so these are all specifically within the project. We have this assets directory wherein we have saved all of the files for all of these images. Yeah, and I believe that's all I have now. So that was a not so quick overview of exactly how all of this code works. Took considerably longer than I was expecting, but in any case, have a nice day.